Now we're going to make the LFS system bootable. So there's two main parts to this: is creating the kernel and installing the grub bootloader, and then there's a few other bits and pieces. For example, the next part, which is the etc.fs tab file, which defines what mount points need to be known by the system and whether to mount them automatically or not. So we'll copy this in to create the default FS tab, and then I'm going to edit it directly. And yes, I thought it had done that. Let's do that again and only do it once. That's better. So what we've got here is some bits we need to fill in. Basically, the first two lines we need to edit. So the first line is the root partition. We need to specify what that is. And if you recall, my root is on STA3 and it's an ext4 type. So I'll put that in. And then the swap is on STA2. And I don't need to edit anything else. The only other thing I need to put in is /dev/SDA1 because that's the boot partition. That's also an ext4, and I'm going to mount that with no auto, so it doesn't automatically get mounted, but the rest of the options I'll use as defaults. I can't remember what I should set this to now. So it says it here. No, I'll set that to 1 to have a dump in the if something goes wrong, and to do it after the main file system check of the main root file system. I can't remember exactly what it dumps now, but it's probably advisable, being the root's dumped, to have the boot dumped. And there's some information there about if you've got an ext3 file system, to add the barrier equals 1 if you've got NCQ on the drive. So that doesn't count for this as it's an ext4. So that should be everything we need for FS tab. So now we're going to compile the kernel. Building the Linux kernel for the first time is one of the most challenging tasks, etc. It says here about information for kernel configuration. You can ask for help. I've actually done a video on creating custom kernel. It's a little bit old now, but it should mostly be relevant. I'll show you where you can find that on my channel. Again, if you go to the playlists, it's one with a red background. There it is there. Viewable playlist. So there's 4 videos there which show you sort of salient parts you need to look at. But for the purposes of Linux from scratch, I found that creating the kernel with the default settings and then just tweaking anything, for example, the network card, I'll need to go in and just check that that's been enabled. That usually is enough to get a working kernel. But if you want to trim it down and refine it even more, that video should help you narrow down the options that are most important. So go back to the sources directory. We need to extract the Linux kernel tarball. Change into it, and we start by cleaning the source tree with make mr proper. So it says to go straight into make menu config. That's not really the best thing to do, it's probably best to follow what it says in this notes box out by running make def config first, and it will configure a default kernel based on the architecture you're using. So you can see it's used something called x86 def config, and it's written that. Obviously, if it was a 32-bit machine, it would use a slightly different default config. So now we can run make menu config. And this is a bit, I said that you need a console that's got at least 80 characters because it will refuse to run if you don't have 80 characters. The first thing I'm going to do is jump straight into device drivers and set up a network card for myself. Otherwise, when I reboot, despite all the configuration I've done for the network, it won't work. So what I need to do is go into device drivers, network device support, come down here to Ethernet driver support. I can get rid of all these. For some reason it defaults to adding in every single manufacturer here, but not necessarily every single device. It just bloats the kernel a little bit. It's unnecessary really, so it's probably best to just go through and remove everything, and it will save a bit of compile time as well. What's the point in wasting time building stuff unnecessarily? And you'll probably find, if you do go through my video to customize the kernel, there's lots of other stuff you might find that's unnecessary. I'll leave that Realtek in because that's the one I want. It's the I can't remember. Oh, it's the 8169, I think it is. So it's that one there I need to leave in. It's sometimes better with network cards to put them in as modules. Some, especially wireless cards, they don't work very well if they're if they're embedded into the kernel. So it's best to set them as modules. So I'll just get rid of the rest of these. Right, okay, so I've done that. Let's go back to the top. Oh, okay, I'll save it. Go back in again. And go through these recommendations that they've got here, which helps ensure that you get a kernel that works properly for Linux from scratch, and no doubt for Beyond Linux from scratch. Although if you went through Beyond Linux from scratch, you'll find there's additional kernel settings that might need to be set for certain tools and programs. One place that's a good place to start is processor type and features, and just ensure that the configuration for the processor family is set. I'd imagine for most people they'd probably want that option there. Oh, as soon as you select it, it goes back. Generic is, yeah, literally that, but the Core 2 will probably optimize it a little bit more for any AMD or any recent AMD or Intel chip. If you've got an older Intel chip, you'll want to select that one. If it's an older, i.e. the early generation of 64-bit AMD chips, you'll want to select that one. And if you've got an Atom that's capable of running 64-bit code, then you might want to select that one. If you're unsure, it's probably best to leave it as generic x86-64. So now let's go through all of these options. So let's go back to the top. Under General Setup, we want to ensure that compile the kernel with warnings as errors is unchecked. So by default, it's got that built in, so we want to get rid of that. Then we need to find the option CPU task time and stats accounting. So there's that option there. We need to go into that one and ensure that pressure stall information tracking is enabled, but not the option underneath it, so that's fine. So go back up one and look for enable kernel headers through sys kernel headers k headers, and make sure that's not checked. That's okay. Then look for control group support. There it is there. Go into that and ensure that memory controller is set. Back again and look for configure standard kernel features. There it is there, and ensure that's not set, so that's already defaulted to unset. Then we can quit that and go to processor type and features and ensure build a relocatable kernel is set. There it is there, so it's already forced set, which is what the dashes are. We can't remove that, there's something else has locked that in. Then check that randomize the address of the kernel image KSLR is set. Well, yeah, that's already set there, so that's fine. Go back and we need to jump down into general architecture dependent options, which is that menu there, that menu option, and look for stack protector buffer overflow detection, which is there and it's already set, as is the next option we've got to set, strong stack protector, so that's fine. Next we want to go back up and into device drivers, then generic driver options, make sure support for U event helper is not set. Maintainer dev tempfs is set, already is, as is auto mount dev tempfs, so that's fine. Go back up and we now go into firmware drivers and ensure that mark VGA VBE EFI FB is set, so check that one. Go back again and look for graphics support, which is normally about 2 screens down. There it is there. Go into that. Ensure Direct Rendering Manager is set, which it is, and then underneath that, so press enter on that. You can't immediately see it, but if the screen was wider, you'd see that there is a dash, an arrow like this, just to the right of that. So just press enter there, and you'll get into the menu below that. And the one we want to look for now is display a friendly message when a kernel panic occurs, which is that option there. Check that the panic screen formatter is KMSG, so it's set to user, so we need to go into that and change it to KMSG, so type that in. Then go into supported DRM clients and ensure enable legacy FB dev is set. Go back up again and look for simple frame buffer driver, so that's down here somewhere. There it is there, so we set that in, so it's a yes to set it directly to a star. If it can be set to a module, pressing spacebar will cycle through the available options. Also, you might want to set your graphics card here. I've got an Intel chip, so it's got an built-in Intel graphics, so I'll just leave the defaults there. But if you've got an AMD, you've probably got a built-in AMD GPU, or maybe even the Radeon, possibly if it's an older machine. And NVIDIA, if you want to use a Nouveau driver, then select that one. So we need to go back up to console display driver support and go into that and ensure frame buffer console support is selected, which it is. So that's that. We'll go back up to the top. If we're on a 64-bit system, there's some additional settings. If you're using menu config, enable in the order of PCI MSI first of all, so don't do them in the order that's displayed here, because certain options won't appear. If you do them in that order, you need to do them in the order that's mentioned here. So we need to look for config PCI MSI first, which is under device driver, so back into there. It's under PCI support and it's a message signaled interrupts is what we're looking for there. So if we do help, it will tell us the config option. You can see PCI MSI, that is the right option, and it's already set anyway, so that's fine. Then do config IRQ remap, so that's this one here. So we need to go back up one and look for IOMMU, which is nearer the end of the list in this section. There it is there. So go into that and then look for support for interrupt remapping. Support for interrupt remapping. There it is there. Check that. And then last of all, it says to do the config x86 x2 APIC, which is under processor type and features. So back to the top, processor type and features, and there's the support x2 APIC option. And again, you can just double check that that matches the config option, and it does. So that should be it. Come out, make sure you save the settings, see if there's anything else to set. 32-bit system, there's one option there. Oh, if the partition is on an NVMe SSD, so this one isn't, it's actually a SATA SSD, but if you're using an NVMe, then you need to set that option, which is, I'll show you where that is, under device drivers, and then there's an NVMe support here, and just check that option there. You might want to include verbose error reporting, which may increase the kernel somewhat, and maybe hardware monitoring as well. Although I haven't got NVMe, I'm going to check that anyway, in case I do put this kernel image on a machine that has got NVMe. So I'll save that. And there's some information about the rationale for choosing these options, what they do. So the next thing we've got to do is to run the make option to build it. I'm just going to time this and wait for it to build. It'll be probably several minutes, I'd imagine. Okay, that's finished compiling, so let's do the next command. Oh, right, okay. I've got the external cable resting on the laptop and it looks like it's pressing down one of the buttons. Right, make modules install, and if you decided to use a separate boot partition for the LFS, the files copied below should go there. So we've created an entry in the FS tab, but we've got to mount it in the true environment, so it's currently mounted from outside. So I'm going to unmount it. Let's see if I've got it set. LFS, I haven't. I'm just going to set it to make sure I don't make any mistakes. And unmount LFS/boot. Okay, so it should just be LFS mounted now. It is. Go back here. So now if I do mount /boot, it should work because it's in the FS tab, and it does. So if I do df-h here, you can see it's mounted there correctly. So I'm going to copy the kernel image to the boot partition, the system map file, which is got symbols for the kernel, and finally the configuration that I've used to build this kernel. Now I'm going to install documentation. It says in many cases the configuration of the kernel needs to be updated for packages that have been installed later in BLFS. Also, you might find there's something you need to tweak in the kernel at some time. So it is best to keep the Linux kernel source directory around, don't delete it, and just modify it. And as it says here, it's advisable to run root 00 on this directory, so I'll do that now. And next time you don't run the make mr proper, just do make menu config, make the tweak, and then copy those files again. If you need to affect how or the ordering of certain modules, then it tells you here what to do, and that's that. Using grub to set up the boot process, as I mentioned before, if you're using UEFI, you need to do things differently at this point. There's a description here of how to make a rescue disk. It's kind of good, I suppose, as an exercise, but you need to install the libiso burn package to get this Zoriso utility. In any case, we're booted from a live USB, so you can use that to boot up and mount the LFS if it won't boot, and fix anything that may need to be fixed. There's some information here about naming conventions. It always confuses me. Basically, you have to remember that the devices start at 0, but the partitions start at 1. So a hard disk will start at HT0, the next hard disk in the system will be HT1, and so on. But partitions always start at 1. So the first partition is 1, the second partition is 2, and so on. So hard disk, the first hard disk, the first partition on the first hard disk would be referred to as HT0, 1. I sometimes have a moment where my brain freezes and I can't quite remember how it numbers, but it seems that it's there to be read. So we've got to run this command to install the bootloader onto the disk. Be careful to make sure that you enter the right device here. If you boot from a different device for some reason, you need to adjust this, but in this case SDA is the correct boot device in this machine, so I'll just run that as it is. No error reported, so that's good. Now we create a config file for grub to use to present a menu to us at boot time. It's just worth checking the kernel name here, because I think once it was slightly different and it wouldn't boot, and it threw me a little bit. No, it looks okay. Next thing I'll do is just check that, because edit it, edit the boot grub.config file, just to double check that the partitions mentioned are the correct ones. So the root is the root of the, I can't remember now. Yes, it's the boot partition. Yes, that's right. This root refers to the boot partition. So the boot partition is actually on this system is actually 0,1. It's the first partition on the first disk. So I need to change that to 1. And this root that's mentioned here is the actual root file system. So again, this needs to be changed to SDA3 because the root file system was on 3. If you recall, I put the swap partition on 2, so this was referring to the swap partition, as was this initially. So this is the root partition, this is referring to the first partition on the first disk, and this is the boot partition, sorry, wrong way around. This is the boot partition. This root is pointing at the boot partition, and this root, which is for the kernel, is pointing at the root partition of the system. Another thing to notice is because I've got a separate boot partition, it's in a different partition. As far as grub's concerned, the root of the boot partition is where the kernel image lies, so we don't need the boot. If I didn't have a separate boot partition, then I would need that boot in front of the kernel, because it is actually a subdirectory. But because initially it's only the boot partition that grub knows about, there is no subdirectory called boot in that boot partition. The kernel image is directly off the root of that partition, so that's why we need to remove that in this case. And that's actually mentioned in that note there. There's some information there about using the UUID to mount partitions, which I've done in other videos of LFS. If you want to do that, I'm not going to bother doing it this time. It's particularly useful if you do install Linux from scratch on a USB stick, or if you've got a machine where you might have USB devices plugged or unplugged, depending on when you boot, because they might change the ordering of the assignments of hard disks. So it ensures that the same partitions are mounted in the correct way. So like I say, if you do want to see me doing that, then look at I think I might have done it in the previous one, if not the one before that. So it'll be 12.2 or 12.1, I've certainly done it. There's a warning there about grub make config, which other distributions use, but Linux from scratch doesn't use it. As you saw, they just copy the files. So I need to save that. Just view that to make sure it's okay. So the boot partition is set, which is called the root in grub, as the first partition, and the root file system for the kernel is the third partition, which is correct, and the kernel is off of the root of the boot partition as far as grub's concerned.